an important result based on infinite series which is convergent. Whenever you find that infinite series summation un is convergent infinite series, directly it follows that limit n tends to infinity applied on nth general term of the infinite series will be equal to 0. For example, we have verified that the infinite series 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus etc. plus 1 by n into n plus 1 plus etc., which can also be represented using the notation summation 1 by n into n plus 1, where the nth general term of the infinite series un equals 1 by n into n plus 1. Here when you apply limit n tends to infinity un, you have limit n tends to infinity applied on the expression 1 by n into n plus 1, which can also be written as 1 by n into n plus 1 equals 1 by n minus 1 by n plus 1. Therefore, limit n tends to infinity un equals limit n tends to infinity 1 by n minus 1 by n plus 1, which can be evaluated as limit n tends to infinity 1 by n minus limit n tends to infinity 1 by n plus 1, which will give us 0 minus 0, which is 0. This is a convergent infinite series, and we have verified that limit n tends to infinity applied on nth general term is giving us 0 as the answer. If you consider this result as P implies Q, then we have whenever P implies Q, it follows that negation Q implies negation P, or we have P implies Q is a logical mathematical statement which is equivalent to negation Q implies negation P, or not Q implies not P, which will mean that here whenever limit n tends to infinity un is not equal to 0, then we will have to conclude that the corresponding infinite series summation un will be divergent. In other words, if limit n tends to infinity un is not equal to 0, suppose you get limit n tends to infinity un equals positive infinity or negative infinity or some other value which is different from 0, in all such situations you can directly conclude that the corresponding infinite series represented using summation un will be divergent. Let us look at an example. We have proved that the series 1 square plus 2 square plus 3 square plus etc. plus n square plus etc., which can be represented as summation n square, is a divergent series. Let us check what will be the value when you apply limit n tends to infinity to the general term which is n square. We have limit n tends to infinity n square equals positive infinity, and it is different from 0, which justifies that whenever limit n tends to infinity applied on nth general term for an infinite series is not equal to 0, you can conclude that the given infinite series will be divergent. Another point is the converse of this statement. If you consider P implies Q, which is a true statement, does it always mean that Q will imply P? It's not compulsory that always Q implies P. If P implies Q, it may or may not be true that Q implies P. So we generally say that Q does not imply P always. It may or may not be true. For this particular statement, we will have to conclude that converse may or may not be true. That is, whenever limit n tends to infinity un is obtained as 0, it may or may not imply that the corresponding infinite series will be convergent. For example, this is the case wherein we found that when we obtained limit n tends to infinity, nth general term is obtained as 0, the corresponding infinite series is convergent. But we have another example which is harmonic series summation 1 by n, which is equal to 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n plus etc., which is an infinite series which is divergent. But this particular divergent series has its nth general term which is 1 by n, to which when you give limit n tends to infinity will give 0 as the answer. Here we have an example in which we observe that even if the considered infinite series which is the harmonic series is divergent, its nth general term un which equals 1 by n, to which when you give the limit n tends to infinity, you are getting limit n tends to infinity applied on 1 by n equals 0. From these observations, it's clear that whenever you get an infinite series, first of all you take the general term un. When you give limit n tends to infinity to this general term, if you are getting its value which is not equal to 0, directly you can conclude that the given infinite series will be divergent. Suppose you have limit n tends to infinity un is giving you the answer as 0. There are two cases which follows. Sometimes the corresponding infinite series will be convergent as in this case. Sometimes the infinite series might not be convergent as in this case. Whenever limit n tends to infinity un is obtained as 0, we will depend on certain tests like ratio test, root test or rabbit test or limit comparison test, which will help us to check whether the given infinite series is convergent or not.